All right, everyone, welcome back. In the last video, we introduced the position argument and how for bar charts, it's by default assumed to be in the stacked argument, and it gives us a stacked bar chart. So in the code that we have over here, I explicitly define the position to be stacked. But if I take out the position and then run our code, we'll get a stacked bar chart. So over here, if we don't want to use a stacked bar chart, we can use some other position arguments. So for example, if we want to go and use the position identity, this gives us a bar chart that will place each object exactly where it falls in context of the graph. So this is not really useful for bars because it ends up overlapping it. So if we look at our bar plot over here, we have something that looks like a stacked bar plot, but things are getting overlapped. So if for some reason we want to go and be using this, we're going to want to go and change our alpha values so that we can have some degree of transparency. So if I were to go and set alpha and let that to be equal to, let's say, 1/5, we'll be able to see a more clear picture of where these points are plotted. But I wouldn't recommend using this for a visualization. But if we want to use something more useful, we could use the position fill argument. So setting position to be equal to fill, we have a stacked bar plot, but makes each of the stacked bars the same height because we're going to be viewing things now in terms of proportion. So over here, we have a better idea of how things look proportionally, but what we lose is seeing how each thing is sized relative to the rest of the data set that we would have usually with just a stack bar plot. So if we can use another position argument, and if we use dodge, we get we have overlapping objects that are placed beside each other, and this makes it easier for us to now compare individual values, and also gives us a better idea of what the distribution looks like for different values. So in this case over here, it seems like everything is kind of proportioned roughly the same, but in the case of the ideal cut diamonds, it seems like there is more of clarity I believe VS2 clarity than there are with other diamonds, where with premium and ideal, they have more SI1 clarity, right? So premium, very good and good. And with fair, we seem like there is more clarity of I1 than there is with other diamonds over here, I guess, at least in the proportional sense. So there's another type of position adjustment that isn't useful for bar charts, but it's useful for scatter plots, and that is by setting the argument to be jitter. It is possible to do this with bar plots, but you get something that is more akin, I think, to modern art than something that would be useful as a data visualization. So I'll just show you what it looks like. We have this over here, and it doesn't really go and tell us anything meaningful. It's definitely something interesting to go and look at. But what the jitter argument does is that it adds randomness. And this is probably more useful for something like a scatter plot. So if we go back to the previous example that we were using with, here, let me go and change that from geom jitter to geom point for this case. In our earlier example, we were plotting the relationship between engine size and fuel mileage. And what's interesting to note, I actually didn't go and notice this, but thanks to reading the text, I got to see this is that there are 126 points plotted, but really there's more like 234 observations in our data set. So we are missing a little bit less than half of our points here. So what's going on over here is a problem that known as overplotting. So this is because our points for these variables are rounded, and because of that, we have no idea of what the mass of our data looks like. So if we go and we set the position argument to jitter, while we lose some accuracy, we do get a better idea of what the mass of our data is and where it lies. So while we lose accuracy on the small scale, on the larger scale, we get to go and have a more improved accuracy of understanding where the data lies. So this tool is quite useful. That there is actually a function dedicated to it, and if you saw it accidentally put in, you guessed it, it's the geom jitter function, where we can just have this written in and we get a jitter plot like so. So I hope you found this video useful, and I hope to see you in the next video. Be sure to like and subscribe. Thanks for watching.